In the last video, we showed that the derivative of the square root of u plus 2 is 1 over 2 times root u plus 2. And we also recognize that the domains of f prime and f are different. For f, the domain, we can include negative 2 in our domain. Right? That just becomes the square root of 0, which is fine. However, when we take the derivative at that point, we'd be dividing by 0. And so the domain of the derivative function is different from the domain of the original function. And so let's speak just generally in regards to that idea there, that there are really 4 different ways that the slope can fail to exist. So first off, the function may not even be defined at a point A. Then you can't even ask what the derivative is there. Second, if you add an infinitesimal to f or to a and evaluate the function there may be undefined. And then finally, 2 other things that can happen. The change in y over change in x may be infinite, or even, which is what we see in this example here, right, at negative 2, both f of u plus delta x and f of u or negative 2 exist, so we don't fail at 1 and 2, but in the third term, if at negative 2, if a is negative 2, then we end up dividing by 0, and really what's happening is the slope is going to infinity. We'll have a vertical slope there. So this example here fails because of number 3 at the point where a equals negative 2. And then we're going to look at another example here where you could have different values for different standard parts. So the classic example for that is the function f of x equals the absolute value of x. So let's remind ourselves how to define that f of x is the absolute value of x. And the way we've looked at a couple different definitions of this, but I'll use the piecewise definition that it's equal to x if x is positive or 0, and it's equal to negative x if x is negative. Okay, so this should make sense. If I put 2 in here, 2 is positive, so it returns 2. But if I were to put a negative 2 in here, and then it would return negative 2, which is 2. And we know that the absolute value of negative 2 is 2. So how do we take this derivative? Well, the fact that it's a piecewise means we already have to kind of break it up into several cases. So we'll look at case 1, where x is positive. Then if it's positive, if I add an infinitesimal amount to it, that still will stay positive. And so then f prime of x is the standard part of the absolute value of x plus delta x minus the absolute value of x, all divided by delta x. And since everything in sight is positive, this is just the standard part of x plus delta x minus x all over delta x, which is the standard part of delta x over delta x, which is the standard part of 1. Whoops. Which is simply 1. So if x is strictly bigger than 0, then no matter what we add to it, any infinitesimal we add to it will be greater than 0. And so the derivative for a positive number will be 1. It's a constant. Second case we have to look at is when x is strictly negative. So if x is negative, so less than 0, then even adding an infinitesimal, right, because it's infinitely small, it will not change it over to being bigger than 0. So this sum is still negative. And so if x is negative, we have that f prime of x is equal to the standard part. So none of this really changes. X plus delta x minus absolute value of x, all divided by delta x. But now everything inside is negative, right? X is negative, so we're going to get a double negative here. X plus delta x is negative, so we'll get a negative there. So this becomes the standard part of negative x plus delta x minus negative x all over delta x. Now this negative x and this will be a positive x, so they cancel. So I get that this is the standard part of negative delta x all over delta x, which is the standard part of negative 1, which is negative 1. So we've looked at the case when x is negative. The derivative will be negative 1. We looked at the case when x is positive, and the derivative is positive 1. So the third case we haven't looked at is when x is actually 0. So what happens at 0? Well, if x equals 0, we're looking at, so f prime, if it exists, which actually we're going to see it doesn't, f prime of 0 is the standard part of the absolute value of 0 plus delta x minus the absolute value of 0, all divided by delta x, which is simply the standard part of absolute value of delta x over delta x. Now here's the problem. What is delta x? Is it a positive infinitesimal or a negative infinitesimal? In the previous ones, we didn't have to care because we were adding it to x, and whether it was positive or negative, the fact that x was negative kept the whole sum negative, and when x was positive, it kept the whole sum positive. But now we're not adding anything to it. We've just got delta x unadulterated all by itself. And so what is that absolute value? Well, it depends on if it's positive. So in fact, this becomes a, we look at two different cases. So this is equal to the standard part of delta x over delta x if delta x is positive, and becomes the standard part of negative delta x over delta x if delta x is negative, which means this derivative is equal to 1 if delta x is positive, negative 1 if delta x is negative. But now we have two different values for different values of delta x, which means our f prime does not exist at 0. We're in, if we scroll all the way back up here, we're in this fourth case where that ratio has different standard parts for different delta x's. In one case, if we put a positive delta x, we'll get a 1. But if we put a negative delta x, we get a negative 1. And so that derivative doesn't exist. So we can formally say that if f of x is the absolute value of x, then its derivative is itself, just like absolute value, it's a piecewise function. Its derivative is 1 if x is positive and non-zero, negative 1 if x is negative and non-zero, and it doesn't exist for x being equal to 0. Let me draw a graph of what the absolute value looks like. We know the absolute value function is a v, so it looks like this, something like that. And so when x is positive, so over here, well, that absolute value is just the line y equals x. It has slope 1. If, on the other hand, x is negative, then the line is f of x or y equals negative x, which has slope -1. But at the origin here, it switches from -1 to 1. And so that hard corner in the graph tells us that absolute value of x is not differentiable. And we'll talk about this more in the next section, but it is not differentiable. I'll abbreviate that for x being equal to 0. And that completes our introduction to the derivative. In the next section, we'll explore the differential, which is related to the derivative, as well as finding tangent lines to a curve giving the derivative.